value. Now, we will discuss in this video how to find the area to the left of a z using the z table. So what I want you to do right now is I want you to locate the z table in the front cover of your textbook or using the inserts in the back of your textbook. So if you have a textbook, you should find the tables there. Now, let's say you don't have a textbook, but you have looked up a z table, or you found the section where in Launchpad where it has resources. Now, if you go to resources, you should see tables, right? And under tables, if you click on tables, it'll take you to some tables. What I want you to do is scroll down until you see the table C. So this is an example of a standard normal distribution table, the Z table. I will refer to it as the Z table. And I want you to get familiar with the Z table because, as you can see, there are two pages to the Z table. Notice that on the left we have Z's here. We have negative values on one page, and then we have positive values on the other page. So we'll be able to locate our Z. If we know what the Z is, we'll be able to figure this thing out. So notice, what I want you to notice is that, for example, let's look at this Z here, negative 3.4. Now, for Z's, or referring to when you find a Z-score, remember that I want you to round your answer to the hundredths place. So for Z-scores, you will always have the hundredths place. Now, if you look at this right here, if I gave you Z equals negative 3.40, notice I have the hundredths place here. Then notice that 4 is in the tenths place, right? So you have this, but what's in the hundredths place? The hundredths place is the number to the right of the tenth place, which is the 0. So for the tenth, you will look at this column, and what's in the tenth place? The 4. For the 0, you'll look at the row. Alright, so negative 3.4 will correspond to this number because it's the intersection of negative 3.4 and 0.00. Alright? Now, let's go over another example that I have included on the semi-guided notes here. So the first example, find the area to the left of Z equals 0.57. So again, let's break down this 0.57. Let me write it a little larger. Now, what number is in the tenth place? 5 in this instance. That's in the tenth place. And what number is in the hundredths place? Hundredths place, the 7. Now notice in this case, our Z is positive, a positive number. 0.57 is positive, so you don't see any negative, so you know that it's positive. So what you're going to do is look at your Z table, and you're going to go to the side where there are positive Z values. So notice here, positive Z values. This is what we're going to look for, the 0.5 on that side of the page. So this is 0.5, as you can see. It's marked out. And then what's in the hundredth place? 7. So you're going to go all the way to 0.07 here and find the intersection of these two numbers. And what's in the intersection? 0.7157. So this is saying that 0.7157, that's the area that will be shaded to the left of this particular z, if z was equal to 0.57. Alright, I forgot to mention that these tables, if we look carefully at these tables that I'm showing you here, these tables only represent the numbers that you see here. So all of these numbers here only represent the areas that is to the left of some z. So notice how they have a little graphic here, and they're showing you that this table represents the area to the left of some particular z. It will never tell you what's to the right for this table C. Only to the left. So if you are asked to find a probability to the left of some z, easy, because it gives you the exact number right here on this table. So it's pretty simple to find the area to the left. Alright, so again, looking at this example, find the area to the left of z equals 0.57. And now, I have a note here. I always remember to draw a picture and shade the area first. So, let me go ahead and do this. I've done it so long, so sometimes I even forget to draw it for you so you can really understand. So, let's say you have a bell curve. Alright. What z value goes in the center? 0 goes there, of course. Then we have 1, have 2, 1 standard deviation below the mean, -1, -2, and so on. Where is 0.57 on this horizontal axis? Well, it has to be between the 0 and the 1. So somewhere here, right? And if it says find the area to the left, where should I shade? I should shade to the left of 0.57. So this area. Now if you just look at it, you should be able to tell that that's definitely more than 50% of the bell curve, right? That's definitely more than 50%. So if I find a value on the table and it's not lining up with what visually what I'm saying, then you know that you didn't do something right. So we know that it should be more than 50%. And again, it's confirmed 0.5 and that 0.07. Notice if we add those two numbers together, you get the 0.57. So you might want to try adding the numbers together and you'll get the number you're looking for. So according to this table, the area to the left of z equals 0.57 is 0.7157, which is what percent? If you move the decimal over 2 places to the right, that's 71.57%. Extra examples, find the area to the left of a negative value. Find the area under the standard normal curve to the left of negative 1.52. So what I want to do is go ahead, and I know that you see it, but what I want you to do is get in a habit of sketching something. So we know that 0 is here, 1, 2, -1, -2. Where is -1.52 approximately? Where is this number here on this horizontal axis? Well, it has to be between this -1 and -2, right? So somewhere here. Now, find the area under the standard normal curve to the left. Wonderful. Anytime we have to the left, we know that we can find this number fairly easily because our table C gives us the exact area whenever we're asked to find the area to the left. So, again, our Z equals -1.52. So what we're going to do, since this is a negative number, we're going to go on the side of the table where we see negative values. And if we recall what we just shaded, we know that this number must be less than 50% because it didn't cover half of that bell curve. So -1.52. So we're going to, in this direction, we're going to look for that -1.5. So let's scroll down until we see the -1.5. So here we go, -1.5, and then we need the 0.02. This is the 0.02 we're looking for. So -1.5, 0.02, intersection of that would be this number right here. So the area to the left would be 0.0643. Let's see if we're right. So here it tells us 0.0643 is correct. Alright, so this area, if you change this as a percent, what percent of this bell curve is shaded? Well, if you move this decimal 2 places to the right, about 6.43% is shaded. Alright, one more example on finding the area to the left of a number. And in this case, we have finding the area to the left of a positive Z value. Let's try Z equals 1.52. So not -1.52, but positive 1.52. Also notice the notation for this. Z is less than 1.52. Means the same thing as this part written out. Alright, let's go to our table and decide which side we should be looking at, right? Because we know that one side is negative and one side is positive. So right now I'm on the negative Z side, and so we need to scroll down until we get to the positive Z side. And what do we need to look for? On the left, we need to look for 1.5. So I'm going to scroll down. And here we go, 1.5 here. And then 0.02. Again, if we add these two numbers together, it gives us the 0.9357. Right? So 1.5 and 0.02, the intersection of those two numbers. And let's go to our table. And as you can see, it was shaded. Everything to the left of 1.52, definitely more than 50% of this bell curve was shaded. So in fact, it was a whopping 0.9357 or 93.57% of this bell curve was shaded. Alright, so this concludes the video on how to find the area of a normal curve to the left of some specified Z value. Alright, in the next video, you're going to learn how to find the area to the right. So that's a little bit different, a little extra stuff going on there. But how do you find the area to the right of a Z value?